machine learning pipeline class. So they'll be there forever, and that'll make this just easier to get to. But it's good to play with the Kaggle API or put data files in your own GitHub directory and learn how to import them into these Google Colab notebooks. Now, of course, if you're using Jupyter notebook on your own PC, it's not as big a problem. But when you're using an online cloud tool like this, it really helps to have them. And I could replace this with a bit.ly link. And let's go do that. I want to show you all how to do that because it can be really handy. So what I'm going to do, and again, we're kind of backtracking a little bit, but doing a little house cleaning or learning how to do some housekeeping on our data. So I'll go over to another tab and I'll go to bit.ly. And it should just auto log into my account. Yes, great. And then I'm just going to create a new bit.ly. I copied that long link into my buffer, my keyboard buffer. And now I'm going to just create a shorter link. And it gives me one. Great. And now I can just click copy here. Now I can go back to our notebook and paste that right. Uh-oh. I think I'm going to want to, oh, well, do it this way. And I think that'll work. Yes, excellent. And then we'll do the other one the same way, just so that they're staying within readable, manageable links. And again, I'm just showing you this process because it would be great for you to be able to do it too. That was a Control X after I highlighted it. And now I'm going to exit this one and create a new one, doing a Control V or a Shift Insert there and create it, copy it, go back over to my notebook and put the bit.ly link in, and voila. Now they're just not so long, and we can go ahead and load our data directly from that GitHub repo. Now, also, when you do that, let me just show you what happened. Over here on my GitHub for our integrated organization, all I was doing was going to our machine learning pipeline course repository, and I created this project data, 99_project data. And it's just got helpful data files in there that I use in some of these classes I teach to you guys, my family. And the one that we just did here was for these Kaggle house prices. But what you want to do is you go directly to the file. Let's see if that's gonna, oh, let's see. I wanted to show y'all there is a way. I wonder if there we go, good. And then right here, you want to, once you're, it took a while to open it, I should have known that. You want to go to raw. And then when you see a page like this, that's what you want to copy right there. Now, you may think, oh, there's some stuff missing. No, it's just Google Chrome hiding it. And let me show you what that looks like. It's that one of those long links we had before. Of course, it needs to be in quotes. And then this is what I copied to put into bit.ly to get the shorter link. So I hope that helps. You can watch the recording if that seemed too fast. But if anyone requests, I'll also write it up as a little step-by-step procedure. So this succeeded in loading each of those data sets, the train and the test. And notice that I then just check it by looking at the head. And it's just giving us a sample here, the first three and the last three for the train and the test in a Pandas data frame. And remember, to use Pandas, we had to import it up here. We're also going to be using Numpy. We're going to be using some stuff from PyPlot and occasionally PrettyPrint, which can be quite handy. Also, this is a good thing to add when you're doing PrettyPrint to just give it some extra information. And indent equals 2, you can change that to 4 if you like to look at it that way better. Okay, that's a little past housekeeping we didn't discuss before. Now, and again, I'm going to blaze through this initial stuff, and we're going to get right into uh, catching up where we were last week. Okay, if I am, now I'm just surveying the column names. That's where I'm using the pretty print. And then right after that, I'm using a describe. This gives us important statistical information on the data set items. Now, I'll just run this again. And so this gives us all the column names, but also all of the information, but it's not really all of it. You could tell that that wasn't quite 83 or 80. We know that we have 80 features in one column. This is nowhere near 80. Why? Because we know we have to do a lot of encoding, and we haven't even gotten to that yet. So we were just dealing with NANs and in general and dealing with our NANs. So NANs are not a number, they're a form of missing values. But before we got to that too, we just did a bunch of histograms. And right now, these are only histograms on the numerical items. This is nowhere near 80 histograms. And how would you do that? Look how easy this is with Pandas. I can't remember if we showed this part last week, but that's how simple it is. And we can change these dimensions so it's easier to view the graphs. But just one of the methods to a Pandas data frame is histogram. Okay, now we go to data cleaning. And we talked about NANs. We talked about how to calculate a NAN density with data frames. Again, I'm blazing through this. You can watch last week's video to see it in slower detail. Then I showed you this method I use to look at proportions of the NANs, both as a proportion of just to the each NAN to the rest of the NANs, and the NANs to all the values. So these are going to be smaller percentages, of course. These add up to, sorry for scrolling so much, but that's part of this class. So this is almost 6% right here. And so this column would add up to that 6%. And this column would add up to 100%. So this is on a of all NANs basis, and this is NANs to all values basis. But you can see that many of the features in this data set have missing values. And that's not all. Many of the many of the features are just text values, and we'll want to deal with that also. So at this point, we're looking at, forgive me, I had a concern I'm worried about. I'll come to the concern later. So again, with this tool, and by the way, if you could make sure everybody has the link to this while I'm chatting. Well, I guess I can put it too. It's a view
Okay,
only.
I'll do that.
Excellent. And it's probably better that we share at the folder level.
Okay.
So the folder that this is in, it has got a bunch of things I've been teaching notebooks that I've been using for these very basic classes. And by the way, y'all are already getting into advanced stuff, because dealing with Pandas data frames at this level and dealing with missing values, that is not necessarily easy stuff. So we'll rerun this one, even though it probably didn't need to be rerun. And now we'll do, we want to see which ones are character based also. So we'll run this and we get this one that's showing that, oh, well, let me double check that. Hang on. Yes. This is a Pareto for the data frame of characters. And but it's also looking for NANs. And I need to review real quick. Oh, forgive me. This was setting up that function. This is running it. There we go. And so again, it's just giving an overview. So I'm sorry, this is just saying it has 0 total nans. So they're being listed right now when nans are present, they're being listed as characters. And if you ever want, sometimes, I don't think it'll work this time, to get rid of these messages like that, you only need to run a semicolon, but that's not in this case, unfortunately. So, okay. Now, we're going to create many temporary columns in our data frame, like I showed y'all last week. So we'll create original columns, an original columns list that we can use to help us remove the extra columns names later. So here's what we're doing, this original columns name. That way, later, for all these temporary columns we're going to create, like I showed you last week, then we can go back through all the training columns that we're going to, that we had
Thom?
originally. Yes.
Thom, may I ask a question?
Of
So there
course.
is no characters in the data set?
There are. Forgive me, I'm not explaining this well, and I think it would be better if I explained that this part later, because I don't want to confuse y'all with what's going on here yet. This was something I prepared that we can use along the way. So let me come back to that, Tamiris, and thanks for catching that.
Yeah, because it only shows the features that has no characters. So it seems
right, but
that
it's set up to say, well, what's the character? And it's a nan. And a nan is something I set up above. So this is so that I can catch specific characters in the data frame. And so I created it to be used later, but I'll show it as we go along. But back to this point, and thank you for the question, Tamiris. So we want to keep this original columns name so we can compare it to a list of all the column names, the ones that we had originally and the ones we're going to add, so that we have a way to remove the temporary ones we're going to create. Okay, so the first in our Pareto, the feature that had the most nans or the most missing values was the pool quality, the pool QC. And so if I go in and we talk to our, this is a fun thing to learn real quick. I should have put this in bold so it would stand out, but this is our domain expert. This is our subject matter expert, the data description.txt file. So we're talking to someone that works at a multiple listing service that handles this data. And we say, hey, for this group of house data you gave me from your multiple listing service, I see there's a pool QC. What is that? Well, that's pool quality. Pool QC equals pool quality. And here are the legitimate values that should be there. So, but there's also a related one. There's pool area. So that's the nice thing about these data description files. They're like our subject matter experts, and we can see everything related to pools. And so I had a first guess. Perhaps pool area equals 0 will correspond to pool QC being a nan. And so the first thing I do is I just look at the unique values, and we see that, yeah, okay, we have excellent, we have fair, we have good, we don't have any typical averages, and we don't have any NAs. So perhaps if I look at pool areas, this is the number of unique pool areas. Not surprising, because there's probably only a few pool manufacturers in this area where people are typically buying the same pools. But there's this 0 that's there. And perhaps some data entry control person had the good sense to say, if the realtors don't enter a value for this, we're just going to make the default 0. So like I showed y'all, and we're reviewing this one in more details because so many of them were done this way. We make this pool area column, we make sure it's as string. And then this pool QC area, we're gonna, and again, I'm sorry, we're leading it with string because we're creating a new column like I hinted at. So we've got string pool area, string pool QC, and we're just using this right here. And this is the way when you have a Pandas data frame that you refer to a column. So each column, it's good for each column to have a header, and that's what the columns were, and that we did above. And so we're just changing it to as string. Now, I'm trying to be empathetic to you guys. I know I'm going fast, but remember, you have a link to all the notebooks in this directory that Hugo's going to share with all of you. And the cleaning Kaggle house prices regression data is one of those notebooks. So while I'm going fast, you don't need to take notes. You'll be able to look back through this and you can play with each cell and each line step by step to better understand them. Now I use this very handy function called aggregate, but I aggregate using this. Join this new temporary data frame called check, or column, excuse me. And what it's doing, it's saying for these two columns in that data frame, join them together or aggregate them using this function. And this join is a function that's used on each row of this temporary data frame here and putting a space between them. And you can, and then on that check column, you can see the outcome here. Boom. All the NANDs go with the 0. All the excellent condition pools go with 512. Excuse me, not all of them. All the 512s go with excellent. And the 555s go with excellent, etc. The goods have 576 and 738 and 480. And the fairs have 519 and 648. But all the zeros had a NAND. So that helps us explain very well. Those entering data did not use NA for no pool, and they did that consistently. They just left it blank. And the programmers of the MLS didn't make sure that defaulted to NA when it was blank. So that's something we could go ask the multiple listing service programmers to do for us. So we didn't have to always do this cleaning. But this also means that out of the 1,460 records, there were only 7 homes with pools. So if we had not done a little investigation, we might have lost the predictive help of pools being present or not. So now I use this very handy function, and this is a travesty as a method name for the data frame classes in Pandas. It says fill NA. It should be fill NAND. That's what it actually means. And it can be quite confusing because we're going to fill the NANDs with an NA. But when we do that, look what happens now when we look at the unique values in the pool QC column. All the NANDs have been replaced with an NA now. Okay, similar things we did before. So I know this was rehashed for those of you that were here last week, but now the miscellaneous features. We see that there's NANDs when there should have been an NA again. That's our likely conclusion. So we look for the unique values of the value, dollar value of each of those miscellaneous features that were included. And it's quite instructive. There's a lot of, there's sheds, there's a second garage, there's other things. There's a tennis court, but there's no elevators. Quite instructive. And so, yes, Tamiris.
I wrote something in the chat. I think this problem you solve this way, you can use a dictionary too. Am I right?
You could.
Yeah.
The reason I'm showing with Pandas, and we do create some dictionaries later, but the reason I'm sticking with Pandas is because Pandas is so powerful for this kind of stuff. Now, it's not to say there's always another way to do something with Python and its modules, but This is one way that I found is very powerful, and knowing pandas is a very good thing.
Yeah, it's the first time I see the solution this way. I see the solution only using dictionary. Is good.
Now this isn't dictionaries, this is pandas data frames right here.
Yeah, but it's the first time I see this way use pandas. I always see using dictionary.
Oh, I see what you mean. Yeah, this is, to me, using it from pandas is very powerful. Now, if you feel like, oh, I know dictionary is better than pandas, yeah, use what you know, but it's really good to get good at pandas. I will tell you that. Okay, now what I did is the same trick we just did. We're going to create a string. We're going to type these as strings just to be safe. And then we're going to do, and by the way, why would we do that? Because the nans wouldn't be as strings. So we can typecast a nan as a string, and that helps us. So here we go. We made sure each of these columns, new columns, were string only versions of these two. These two are. And then we created a check again. So we're overwriting the old check. That'll reduce the number of columns we have to remove. And it's string miscellaneous feature and string miscellaneous value. We aggregate it the same way, and we look for unique combinations of those. And look, 0 always goes with nan. So again, we know to fill the nans with NA, and then we look at the unique values again, and sure enough, we successfully replaced all the values with NA. Now, we did similar things for Ali, and this one was even easier because we could just see that, yep, all the nans should have been an NA. We did a similar thing with, sorry for the scrolling, I know that drives people crazy, me too. But now we did the same thing with fences, and fences was pretty easy. So we did just a direct replacement of nans to NA. And this does, every time we're doing this, we're making we're preparing for better modeling. If we had just, removed these columns and not used them, it would have, each one would have hurt our predictive ability a little bit more. Now, again, here's one where we need to do this combination trick you saw me doing above, but this again was for fireplaces. And we learned that, yep, 0 always goes with nan, so that was good. We did that replacement. And then we got to this tough one. And I think this is where we left off, right, Hugo, son?
Right.
Well, we did
that's it.
Okay, excellent. And we did, now I know we're already at the half hour. I apologize for that, but we did a lot of new stuff above. We got the import fixed. You saw how to do that. If I went too fast, you can do the recording. If y'all ask me for a procedure, I'll show you. But it's as simple as getting a copy of that, putting it in a location of your choice on the web. Hopefully, I think GitHub's great. Finding the raw link to that, and then you don't have to go get a bit.ly URL for that. You can just use the full long one, and then you can use that trick that we did at the top to get in that data. So that was a good addition. Probably seeing this again didn't hurt for those of you that saw it last time or didn't see it last time. But now we've got this lot frontage. Now, just so y'all know, I have been both a real estate investor, well, probably still am, a real estate investor and a realtor. And I was a bit confused about lot frontage, but it's really just the linear feet of street connected to the property, meaning how wide along the street is your property. So a crazy example would be someone has 1,000 square foot lot, but it's 1,000 square feet right there on the street. That means it's only 1 foot deep, just to give a silly example of what this means. But it's also kind of related to lot area. And a lot of here are all the unique values. So there's quite a few unique values, and then a nan is among them. And this is a numerical nan, not a string nan. So I started really questioning this one. So there are 110 non-nan values, non-nan unique values. Let's look at lot area and then do our previous correlation of value tricks. So we do this. This is there's 1,073 unique values for lot area. And if we do this trick again, where we typecast lot frontage and lot area as string columns, that in other words, all the values in them are strings, and then we aggregate those strings together, and we're going to just see, well, how many unique values are there then? And there's 14. And of course, we could have just printed, we could have just looked at the unique values from the train. In fact, just so you know, why don't we do that? Let's create a new cell here and look at those separately. Notice a trick here in notebooks. If you just print this as something like this as the last line, it'll assume that you want to print that. And so here are those unique values. Oh, shoot. This needs to be, oh, there's a typo here. Forgive me. I'm glad we caught this. That was looking at the stuff above. Okay, so that means there's 1180 unique combinations here. And if we print this now, we really need a string check here. Okay, when we see these ellipses here, that means it's cutting short. It's just showing you an example of all these unique values. So that just means there's a lot. So something different exists here. Let's isolate those values with nans in them. And because we know we couldn't have 0 lot area, but there's yet still a lot of missing values. So sure enough, some realtor just did not, or a group of realtors didn't enter anything for lot frontage. And look, it's all those values. So when you're frustrated about how long one of these is, go over here to the edge, and now you can scroll the actual window. So that's just too many 0 nans to look at. So I'm going to just blitz that. And then, so it shows that all cases where lot frontage is nan, the home has a lot area, of course. Well, is lot frontage important? Well, the more you have, the more space there is between houses. So think about that. This gives you more room between you and your neighbor's home to do things you want. So perhaps we should impute this missing values. The concern, there are many missing values for lot frontage. Could these be collinear with lot area? Let's check. So we just do it this way first, where we've dropped the NA and we look at the relations. And then another way to check the collinearity. So basically we have enough data to see the correlation between these two features of lot area and lot frontage. Now again, correlation, when we have strong correlation between features, we call that collinearity. It's not that you can't get an accurate model with collinearity present, but you can't get an accurate Pareto of features when collinearity is present. What is a Pareto? It's just a list of the importance of the features. So it's very valuable to know this is the most important feature to the model. This is the second most important feature, and so on. That's a Pareto. It's named after the Italian mathematician Pareto, P-A-R-E-T-O. And so they're very valuable summaries of the importance of aspects or features. So we're going to do that drop in A again and do a correlation on this lot area to frontage. And again, this simple thing, we're just not going to look at the values that have the rows that have an NA in them for these two. That's basically a pairwise deletion that way. And then we're going to just correlate this new um, miniature data frame. And sure enough, now you want to see ones on the diagonal. That just means lot area is perfectly correlated to lot area. If you didn't see 1.0s on the diagonal, that would be a concern. But this is a pretty strong correlation. Now we could say that we should just therefore only use lot area, but I think it would still be good to do the missing values. So let's see what happens here. What am I doing here? I'm now including sale price, so I can see how does the lot area correlate to sales price. Now here we want a strong correlation. Here we did not want a strong correlation, but this is strong, but not super strong. In other words, what I'm saying is based on these values, I would not just decide to remove lot frontage. But this sales price, look, I would have thought lot area would correlate stronger to sales price than lot frontage. But no, for these values that we have, lot frontage is actually a little stronger. What does that really mean? A home buyer, was taken in a little more, 4% more, proportionally speaking. We're not saying it's a causality, we're just saying it's a correlation. 4% more often than lot area. Now, we could do a hypothesis test to say for this amount of data, does that really matter? But I'm just looking at this from this level and saying, yeah, I want to really work harder on lot area. So let me read the lot frontage and lot area do not have a strong correlation to one another. It's there, but it's not super strong. However, they do have a stronger correlation to one another than they do to sales price. And lot frontage correlates, I should say, mildly stronger to sale price than lot area does. Thus, we'll use a regression model to impute. That just means predict. Replace the missing values with predictions. We're going to create, with this data set, we're going to create a separate predictive model that's not predicting sales price, but it's going to, for those rows that have lot frontage and lot area, we're going to use lot area and sales price as predictive as the feature inputs, and lot frontage will become our label. See how we're switching things around? Because right now, sales price is the label. All I'm saying is we're going to make it one of the features, and we're going to let lot frontage be the label, and the rows that have a value for lot frontage will become our training data, and the rows that have nans for lot frontage will become our labels that are missing and we need to predict values for. So this gets back to, let me show y'all, where did that go? Bring it in real quick. I'll just not maximize that. Sorry, there it is. I'm getting another view for you guys real quick to show you something important that I've shown you before. Okay, now we can move. So what I'm getting at is this is the machine learning pipeline. We load our data, we explore it, we visualize it, we clean it, we condition it. We're in the cleaning stage now. We start in this series that Hugo has organized with me. We started with modeling, then we went backwards to see why we would need to engineer data or features. Then we went backwards from that to learn why we would need to reduce features. Then we went backwards from that again to figure out why we would need to condition features such as scaling and encoding. But now we're gone backwards still again on the cleaning. But what I mean by all these crazy arrows, and they're not meant to be exhaustive, meaning that this is, don't treat these arrows as literal. It's just saying, what are we doing right now? We've got a model, and there would be an arrow that's saying we need to go from cleaning to modeling and back to cleaning. That's all this means. Don't consider that these arrows represent all the possibilities. They're just trying to say the pipeline can be very acyclic. So, and that begs the question, why call it a pipeline if it's not perfectly in serial? It's not, it's acyclic. And so what we're doing is we're seeing, we need to replace some missing values by predictions. So we'll go to modeling, and then we use a model to clean the data, meaning replace those missing features. So that's all we're saying here, but we're going to do that later. But I wanted to just talk through that, because then we'll use a regression model to impute 259 missing values. But we should wait to do this until we finish our exploratory data analysis and doing these easier cleaning exercises. So now we look at the garage, and this is interesting. We have 81 not a numbers nans for all the garage related data. So our data description file shares the following about garages. We've got the type, we've got the year built, we've got the finish of the garage, we've got the cars, what's the car capacity of the garage. We've got the garage area, the garage quality, and the garage condition. Wow, I'm sensing some low-lying fruit that is easy to pick. That this slightly an easy fix, even with all of these. So these are the column names. I notice I probably should call this garage column names to keep it separate, but we'll go ahead and use my sloppy version. And then we're just going to create a garage data frame. And we're going to create it from these column names, or these columns in the original data frame that had garage in them. I can't stand it. We're going to at least do this. Just make it a little cleaner in the long run so we don't get confused as we go down. And so now we have that garage data frame. We've got this nice representation of what that looks like. And oh, this is interesting. Whenever there was a garage area 0 and garage cars 0, look what happened most of the time. We can do our trick that we've been doing, but this time I get to just put in column names. Now I got to be careful because I did that cleaning of my own coding above. We want to say garage column names. So what did I do here? First, I did check equals garage df. Garage df is in a, okay, this is just saying for every row where there's an NA, we are making it called check. And we're saying check is now a string type. So this is my trick to turn all those nans into a string, so that when I join these together, it will join easily. And it's also going to do that with the zeros. Or, no, it won't. Yeah, it'll automatically turn the zeros or the numbers into strings. So that's how I get this. So wow, every time I had nans, I also had zeros. That's why I say score here. I think we can assume that when garages have 0 area and hold 0 cars, there is no garage. Now, the proper entries for garage quality, finish, year built, type, condition should have been NA, not NaN. So we'll replace those. Now, if you were doing this for a company and there was an MLS you were working with a lot, it's kind of a crapshoot here. Should you call every one of those multiple listing services and saying, hey, would you please make your realtors enter NA, or at least make it the default value if they don't enter something? And that guy might quit back saying, I have a big list of things to fix in our code. I bet you already have some data cleaning routines to deal with this. And you might, snip, snap back at each other, but he's right in a way. You do this once and it's going to work for most MLSs. You may have to change a thing or two here and there. But now I'm saying fill all of those with NA. And by the way, we could have done, oh shoot, that filled that, but wouldn't it be nice to run this one again, just to look? And so we'll add that code here. I must have been lacking curiosity or a desire to check. Let's see. Yeah, that's just on check. So really what I want to do, that's just in that string check column. So what we really need to do is, if we're going to do this, we should have renamed this garage column names like we've been doing. I hope y'all appreciate why I'm doing that, because I've got all these array names for lists of column names, and I'm just trying to keep this one separate. So what we'd like to do is just make sure, it's just a check to make sure that all that happened, but we could just trust it too. So at this point, oops. We'll just look for that being unique. And we should get a bunch of, oh, yes, I would have to do, that's why I didn't do this, forgive me. I'd have to do it on each of the columns. So we'll just forget that now. But from what we've seen above, we know that fill NA is working good on what we've been doing. Oh, and I could have messed things up, but we can rerun the notebook to fix it. But fill NANs with NA. Okay, now this is going to get a bit more complicated, the basement stuff. And with this one, we'll be able to blaze through these, but this basement one ended up being the hardest one. So again, looking at our descriptions.txt file, we find that these are all the things to do with basement. And I was originally hoping that no basement would correlate with the NANs, but nope, we have these rare cases where there were just some of the basement types had values when there was also a NAN present. So we can't count on it always being NAN and zeros this time. So we have to do something a little more clever. Here's yet another case where we have a mixture of NANs with legitimate things. So let's check this one with one other view to make things simpler. Now, in case this is going too fast for you, and I hope it's not, remember, this is recorded and you can get to this notebook later to really think through things, but I am trying to go at a comfortable pace. So now we're just going to have check be the data frame that's got where we're looking at the cases where we do have a NAN on the rows, or excuse me, on the columns, and that's axis equals 1. And then we'll convert all those to string, we'll aggregate them like we've been doing, and we'll see, okay, here are those column names for just the basement, which we did, forgive me, I should have done basement column names, I know, but we renamed that short column names to this, so we're okay. Just I would encourage y'all to call it BSMT call names. But again, there's just these couple of strange cases. We either have all nans with zeros. And then there's these two cases here where we actually have nans mixed with legitimate entries. So how do we handle that? Well, this is my suggestion. First, we create this basement data frame from our basement column names. And we create this check data frame that's just, it's really just going to be the rows and columns that have nans for this case. So again, we have the basement data frame from this, and then we're looking for only those that are NA, and we're just going to print the length of those. So there's 39 of them as we suspected, and we're getting that. It's kind of a repeat of what we did here, but I was just looking at it from another angle. In other words, I also wanted to add how many of them are there. Now, this is a lot of talk here, and we're getting close to time. I want y'all to show up for Guy's class. He's doing great teaching on classification, supervised machine learning. But of all the basement stuff above, there are only 2 rows that receive NaN values that we might not understand. Let's see if we can rectify those 2 values. So for the second unique row above that has a NaN in it, we find NaN applies to basement finish type 2. And there is a square footage reported for basement finish type 2. So what do? Well, we're pretending that we are creating a model that we can use for all new data that might flow in. In other words, this is an automated cleaning method going forward. We wouldn't always do these in a notebook. We could, but we could put them in a Python script and run all of these, boom, with the data that we loaded. So we automate everything we've been doing above. And we want to be able to automate this all as much as possible for the whole pipeline. So for 1 out of 1,460 values, and having no great way to know, and not having enough data like this to do a model, let's assume finish types with some square footage are unfinished when there's a NaN to be conservative. So then we can automate that. And it's a good and safe assumption. It's a conservative assumption. So for the second unique row above that has a NaN in it, we find that the NaN refers to basement exposure. Well, this feature is for degree of exposure, meaning some basements are daylight basements. That means the house is probably on a hill, or there's an area carved away where one side of the basement's exposed to the outside world. So given the trends of data in this data set, I think it's safe to say that NaNs for basement exposure are no, meaning no exposure when there's a basement square footage. So we can automate that too. So it's just some, and I can talk this way because I was one of them, or I guess I am one of them, realtors, lazy realtors. Thus we'll create, and I'm probably guilty of these data entry faux pas too. Thus we'll write code to automatically handle these 3 cases. NaNs become NAs, where all square footage numbers are 0, and they become the lowest condition when any of the square footage columns are non-zero. So again, that's a form of ordinal encoding that we would deal with later, and that would be in the conditioning phase. So all I'm doing here is saying, okay, I've got my train DF, and where I have locations where this is my method to handle this. These are called masks. So I'm doing sorry for that, keep coming up. I'm doing a long logical mask to say that anytime the finished square footage for basement 1 or 2, or the unfinished square footage is any of these are 0, we're going to enter an NA. And this Q names is up here. In other words, it's including this amongst this mask to create this data frame. Now, even if I talk through this very slowly, you'd still want to play with this on your own to understand what's going on. And remember, create toy data, create fake data that's really small so you can visualize what's going on with these things. Once you do that with something like this, this will be in your mind. You'll go, oh, I get it. But it's basically saying put NA for all of these these values that are in the quality names. That's Q names, quality names. And then these square foot names are these guys. So I ended up not needing those, but I could have used them. And then the same thing with the other one. When there's conditions of these, we're going to do for column name and condition in zip these together and say, forgive me. Yeah, it's looking, and the column name has a nan in it for these column name zips together with these conditions. So it's looking for combinations of the column names we have and these conditions. Zip's just a way to put two lists together so that each element from each list is in a separate subarray. And then we're saying it equals conditions. And so, or equals condition, but the condition will be related to each condition we get from here for the associated quality names. Again, even if I talk through this very slowly, if you're not getting it, play with it and look at it in greater detail. And it may require a lot of Google searching to get to what you need. Okay, now if we run that, and that's, if you're new to Pandas, I can imagine this is very confusing, but you have a starting point to go study it from here. Now, we rerun our basement surveyor to check that everything got cleaned correctly. And sure enough, there's not any case where we have nans in any line. Everything's been cleaned up by the logic we dictated above. And then now, no dirt left in basement data. Let's rerun our Pareto. I will look at this. We only have these three more to do. These three were very similar to what we've already done. And this lot frontage, that's the one left to do the imputation with, the predictions. So you guys have this. You can look through the rest of it. And then Hugo and I will be talking to y'all and figuring out what would be best to do next. Like, should we call this group of sessions to a close, or should we maybe work through a whole Kaggle data set together so you see how all of this comes together on more complicated things? For example, we went through all the basics with machine learning now. There's some things about loading data we haven't been through in this class, and there will always be, just like data cleaning, you can't learn it all in one class. You can't learn all the data loading techniques in one class either. But by starting with what we've done in this series that Hugo put together and we've all done together, this is a good basic start. I hope you can appreciate how important the data cleaning is. And we've just dealt with nans. There's other things we could deal with. You might be thinking, well, when data is in text form and we need it in number form, isn't that cleaning? No, that we call that conditioning the data. And we did do some examples of that in the basics class. So forgive me, we don't have time. Oh, you're welcome, Tamiris. We don't have time for more Q&A here, but Hugo and I will survey you guys and figure out if we should go on. Sorry, this was so rushed, but there was just so much to go through with this data set, and I hope I see y'all in Guy's class. Okay, Hugo? All right. I think he's probably chasing my grandson around the house. I'll see y'all over in Guy's class.